So we started with this topic. What is Numpy, and we have seen some basic things of Numpy. Let me show you what we have seen till last session. How to install Numpy, what is Numpy arrays, why to use Numpy arrays, right? How to convert list into Numpy arrays, and why to convert list into Numpy. That also we have talked about. Arrange function we have seen, zeros and ones we talked about. Now let's try to start with the next one, that is lean space. Lean space is a method which is available in case of NumPy. Let's see how to make use of that. Let me create a new notebook here. So first of all, import NumPy as usual, because whenever we are going to start with a new session, you need to import NumPy. So I am going to import NumPy as np. Okay, and once it is import, I have already told you, right? You just need to type np and then type np, then dot, and then press tab button. You'll be able to see all the methods which you can apply on NumPy. So out of all these methods, I am going to make use of lean space. Lean space actually stands for linearly spaced elements. So lean space stands for linearly spaced. So we can generate the numbers which are linearly spaced. Let's see what do you mean by that. For example, if I go and if I try to call it like this, 6 and run. Okay, so it is going to give me error. For example, I don't remember what are the arguments. Go here, press shift tab. So it is going to show me start and stop is going to be there, and how many number of linearly spaced numbers you want, that number is there. So suppose I want to start with 5, I want to stop at 20, and I want 4 linearly spaced numbers. Right, now what do you mean by this? That means starting with 5 ending at 20, I want 4 such numbers which are linearly spaced. That means the distance between them should be same, right? So for example, if I say maybe I want starting with 1 ending at 10, I want 5 linearly spaced numbers. So which are those? That means you are going to divide this into 5 there will be 5 divisions I can do. So 1 to 2.5, 2.5 to 5, 5 to 7.5, and 7.5 to 10. So see, I got 5 numbers, 1, 2.5, 5, 7.5 and 10. Between 1 and 10 which are linearly spaced. Similarly, if I want 4 numbers which are linearly spaced and they should be between 5 and 20. So one is 5, another is 20. We need to find out 2 other numbers. So one will be 10 and another will be 15. So you can see the distance between them is 5. Distance between every one of them is 5, 5. That's why they are called as linearly spaced numbers. So that is nothing but linearly spaced numbers. So what it is going to give me? It is going to give me 5, then 10, then 15, then 20. Because 4 numbers it is going to give. Let me run it. Now see 5, 10, 15, 20. This is called as linearly spaced number. That is the distance between the current number and the previous number or the next number is same. Suppose if I go here in p dot, and one more point, try to notice that lean space has given us one dimensional array. It has given us vector as the output. Okay. Now suppose if I want to generate linearly spaced numbers, lean space, maybe I want to start with 1, end at 10, and I want 5 numbers. So you can check 1 is there, 3.25 is there, 5.5 is there, 7.75 is there, and 10 is there. Similarly, you can go and you can apply this one to anything, whatever you want. Suppose if I go here and if I try to write 4, so what I will get is 1 is there, 10 is there, absolutely, but 2 more numbers I am going to get. So 1 is there, 4 is there, 7 is there, and 10 is there. So these numbers are called as linearly spaced numbers. So that's what we make use of. So obviously there is a difference between linearly spaced numbers and arrange. Arrange just gives us the range, right? It is not going to give us the linearly spaced numbers. np.arrange, if I go and if I try to type, what it is going to give me starting with 5, ending at 20. So I can go and I can generate the numbers, right? And what it is gives us, it gives us the step size. So step size I want 3. So see what it has given us: 5 plus 3 8 plus 3 11 plus 3 14 plus 3 17. But what is this? Try to understand the difference between those people who are asking the difference between np.arrange and lean space. The difference is that this is start, this is also start. Okay, this one is stop, this one also is stop. But this is number of elements, how many number of elements you want, and this one is step. This is not number of elements. See, what I can do is, even if I go here and if I type 100 or 200, whatever I type, those many number of linearly spaced numbers I am going to get between 1 and 10. See, that's the difference between mean space and arrange. Is it clear, Sharon? Does it clear your doubt? This is nothing but, this is not step. This is nothing but what? Number of elements. How many number of linearly spaced elements you want between this and this? Is it clear, Sharon? Just let me know. I will move forward. Okay. So yes, try to understand that. Just by with the help of arguments only you'll be able to understand what the difference between the mean space and arrange. Okay, that is one thing. Let's move forward. Let's say another thing. So like this, you can let's see start, stop, and how many number of elements you want. That is nothing but this n. Okay, that's not a step size. And I, you people might be knowing about identity matrix. So how to create an identity matrix? np.I. That's what we make use of. And if I go here and if I try to write 10, I am going to get 10 by 10 identity matrix. And it's a two-dimensional array. That notice that by default you are going to get output of np.I as two-dimensional array. It is not 1D array. By default it is 2D array. Right? That is one important point. Generally we make mistake in that. np.identity, if you want to make use of, you can, but I is also used for identity matrix, you might be knowing. And why to worry about the identity matrix here? Because you might be knowing that a into a inverse gives I, right? Matrix multiplied by inverse of matrix always gives you identity matrix. So to derive other matrices, we can make use of identity matrix. They are not, see, np dot, those people who are talking about np dot identity, right? It depends actually. There are obviously there will be differences in terms of there will be differences in terms of the arguments. That's it. There is no other difference. It is going to return identity. If I go here, those people who are talking about this one, see, this is also going to be the same thing, right? It is just that there might be some differences in terms of arguments. Otherwise, you will see that this also gives us the two-dimensional, right? So you can use I or you can use identity, one and the same thing. Okay. Then this is something important: random numbers. How to generate random numbers with the help of Numpy. So I am going to discuss this thing because we are going to read it. Okay. So just try to be clear with this. np dot, so again, to generate random numbers we have different methods according to Numpy. So what we can do is np dot random dot ran. This is the first method you can make use of to generate random numbers. Another one is np dot random dot rand n, and one more is np dot random dot rand int. These are the three methods which you can make use of to generate the random numbers. Okay, and this is how you can generate random numbers. So what this does is it gives us the random numbers from uniform distribution. What is uniform distribution? That we will see. Okay, this gives us the random numbers from what we can say normalized distribution. That means what? That means the values which are centered around zero. Here you are going to get all the values as positive values. Here you are going to get positive as well as negative values, and this rand int is going to give you integer values. Let me show it to you one by one. Okay, so see, Numpy package we already imported np dot random dot ran, np dot random dot ran, and if I go and if I type F5 and run, okay, you will be able to see five numbers which are generated. Just a minute. So sorry about that. 1, 2, 3, 4, and 5. These are the five numbers which are generated. Right, but try to see those numbers are generated in what fashion? 0 point, 0 point, 0 point, 0 point, 0 point. So all the numbers which are going to be generated are between 0 and 1. So that is called as uniform distribution, and every number is positive, right? Just try to understand that every number is positive. That is called as uniform distribution, and that's why you make use of np.random method to generate the random numbers. Like this, if you want to generate any number of random numbers, you can go and you can generate np.random.rand. And suppose if I want to generate 1000 numbers, you can go and you can generate that. This is just a representation of the values. Okay, actually this is just a representation of the value. Otherwise, if you will ask me what is this, those people who are aware about basics, that they might be knowing. This is just a representation. So see, you can generate all the values which are positive. So for understanding purpose, what I will do is I will generate 10 values. Now see, you can see every value is positive value, right? So that's what uniform distribution is. Now np dot random dot, another one is rand n. Let's see what this random does. As I told you, random is going to generate the values which are centered around 0. That is standard normal distribution. Now, standard normal distribution or normal distribution itself is a separate topic, okay, which is not mentioned in your syllabus, right? But just in a short, if I want to tell you, standard normal distribution is like which gives you bell-shaped curve. If you go and if you try to see the distribution of data which is in standard normal distribution format, it is going to look like this. This is called as standard normal distribution, in which the mu is 0 and standard deviation is 1. That means mu is nothing but the mean or the average, and this is nothing but standard deviation. Again, as I told you, it's a separate topic. Don't worry about this particular thing here. Okay. So what will happen is, for your understanding purpose, what rand n is going to do is, here I did not give any number, so generate any random value. See, it is random value. So the third time if I run it, again a random value. Same thing here also, it is going to give me random value. These values are going to change. They are random. Random means every time they are going to give me different values. Suppose here if I go and if I try to type 10, now see what type of values it is going to give me. It is going to give me random values, but those random values, some of them they will be positive, some of them they will be negative. That is called as the standard normal distribution, and it is always centered around 0. Always remember, right? So that is called the standard normal distribution. Random. Like this here also you can go and you can generate as many number of standard normal distributed values as you want. That's possible. So why are we learning all these things? Because we are going to need these things to generate the data as per our requirement, and many times to implement different logics which we might need in different projects. We need this. That's why they are very important. So np.random.rand we have seen, np.random.rand, and also we have seen. Now the third method in case of random is np.random.randint. Okay. Now this is simple. It is just going to generate the random integers. See, it is going to generate a random integer between 0 and 5. So it generates 2. It will generate lowest value, but it will never generate the highest value. That means it will sometimes it will generate 0, but it is not going to generate 5. It is never going to generate 5. See, I will again run it. Now it generated 3 because it's random. Again I will run it. Now we generate 1. Again I will run it. Now we generate again 3. Once again run it. Again 1. It might generate 4 also, but never. See, 0 also will generate, but it is never going to generate 5. Right? So if I go here and if I try to generate it like this, np.random.randint, and if I go here and if I try to type 10 comma maybe 20, so between 10 and 20 it is going to generate random numbers. See, 19 it has generated. So if you do not give starting point, by default the starting point is 0. This is the ending point. This 20 is the ending point here. This 10 is the starting point here. Right? If I go and if I try to run it once again, it is going to generate other random number other than 19 in between 10 and 20. See, 12 it has generated. Again, if I go and if I run it, again 12 generated. Again run it, 18 generated, and so on. So if I go and if I try to run the same command, but this time with number of random elements I want between 10 and 20. Suppose I want 5 elements between 10 and 20. So now in this case it is going to generate 5 numbers which are between 10 and 20. Now see, 17, 14, 10, 12 and 18. But obviously 20 is not going to be there. If I go and if I run it once again, I am going to get 5 numbers once again which are between 10 and 20. Now see. So and because they are random, right? Because np.random, random means every time you are going to get different numbers. So I hope you people are able to understand what we mean by np.random.rand, randn, and randint, which are very important, which we will need many times. That's what I am telling Saloni. Where do we use random values? You can use random values to generate games, to create game applications. You can generate random values to in deep learning. You can generate random values. You can use random values in your data sets, right? Whenever you are trying to clean your data set, whenever you are trying to do pre-processing of the data set, in that case we need these values. Whenever we want to impute missing values, whenever we want to handle missing values in our data set, we are going to need random values. Is it clear, Saloni? Does that answer your question? These are some of the things where we are going to need random values. Okay. So Sharon is asking, so in 32 it will not generate 10 and 20, right? No, I have in 32, if you are asking, it might generate 10, it will never generate 20. Is it clear, Sharon? It might generate 10, it will never generate 20, right? Higher value it is never going to generate. Okay, so that's what these are the methods actually in NumPy, with the help of which you can generate random numbers. Now moving forward, so these are the examples: rand, randn, and randint. Okay, now let's try to talk about array attributes and methods in NumPy. So this method you are aware about now. ARR is equal to np.arange 25, right? So let us see how many of you will be able to identify it correctly. Now tell me, if I suppose, if I run this ARR, now tell me how many elements I am going to get in ARR np.arange of 25. How many elements I am going to get and which are those? Can you just tell me? I already run it. Just tell me how many and which are the elements I am going to get in ARR. So 0 to 24, right? Yes, that's right. Let me run it. Now see, 0 to 24. These are the elements which you are going to get in ARR. Yes, 25 elements, 0 to 24. So our ARR is having 25 elements, 0 to 24. Now let me run another. Let me get another array and see, it's a 1D array, okay, one dimensional array. np.random.randint 0, 50, 10. Now tell me how many elements I am going to get. How many elements in RAN ARR? So yes, 10, absolutely right. 10 elements I am going to get, right? So if I go here and if I try to run it and if I show you RAN ARR, shift enter. Now see, I got 10 elements, but they are random. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But they are random because they are in random. So now our ARR is this and our array and ARR is this. Now let's try to see some methods based on arrays which we are going to make use of. Reshape. Reshape is the method. Okay. First of all, let me talk about. See, both of them, they are one dimensional array. Array name dot shape method is going to give you shape of the array. Always remember, as ARR is one dimensional array, one dimensional array shape is always shown like this. 25 comma. Why 25 comma? Because we have 25 elements, and comma and nothing, because there is no column. It's a list of elements, like a list of elements only, that collection of elements only. So this is how one day array is represented. That means ARR is one day array having 25 elements. Now let me try to check for array and ARR. So what I am going to get is how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 comma I am going to get, because there are 10 elements only. Now suppose if I want to change the shape of this from 1D to 2D, what to do? So what I can do is I can make use of ARR dot shape of 5, 5. So what will happen? This ARR, in ARR, what do we have? If I want to show it to you once again, in ARR there are 25 elements, 0 to 24. Now they are looking like this, but I want to, it's a 1D array. Now I want to convert this into 2D array. So I can convert that into like this: 5 rows and 5 columns. So if I go here and if I shift, if I try to, I think I will have to do brackets here. Okay, so and run it. So put the brackets correctly. What's happening? Okay, sorry. It should not be shape. It should be ARR dot reshape. So ARR dot reshape 5, 5, and then run. And now see, those 25 elements, these 25 elements are written in this way. Why is it so? Because it is converted into 2D array. Now see How many rows? How many columns? 1, 2, 3, 4, 5. 5 rows. 1, 2, 3, 4, 5. 5 columns. Now you people will ask me why there is a need to convert 1D array into 2D array. The best example is image detection, or object detection in the image, object detection in the video. There we are going to need all these things. Okay, so that's why this is very important. So this is what reshape is the method which we can make it, right? And again, if I go and if I try to check ARR, my ARR is not at all changed. Okay, if I would have wanted to select this or save it for permanent purpose, then I would have to do it like this. I would have done it like this, but I just tried to do it like this, and that's why I'm able to see the output here. Right now, so this is what my ARR is. Okay. If I go and if I try to write down ARR dot reshape of 4 comma 20, no, oh, sorry, 4 comma 5. Can you people tell me what will happen in this case? ARR dot reshape. Sharon is asking when we reshape that becomes the latest value of ARR. No, Sharon, no. That's what I told you. It is not going to become the latest value of ARR. See, the ARR value is earlier on. Is it clear, Sharon? Yes, if you want to assign it, then you assign it to some variable. Yes, that's what whatever you are saying. I mean, that's right. ARR dot reshape 4 comma 5 is going to be invalid because how many elements I have? 25 elements, and 25 you cannot write down 4 into 5. You might be knowing, right? Total number of elements in a matrix is equal to number of rows into number of columns. So this is going to give me error because we cannot reshape array of size 25 into shape 4. So it can be 5 5. Yes, it is possible, or otherwise it can be ARR or reshape of maybe 25 comma 1. Now see, you can check it. 25 comma 1 it has worked because 25 into 1 also is 25 elements, right? Or otherwise it would have been like this: ARR dot reshape of 1 comma 25. Now can you people tell me, is it 1D array or 2D array? Whatever you are able to see, is it 1D or 2D array? It's a 2D array, right? So I mean, you are saying 1D, it is not 1D array, it's a 2D array. Just try to check. That's why I told you how to identify 2D arrays in 2 square brackets, starting 2 square brackets, ending 2 square brackets. That's why yesterday I told you how to identify 2D arrays. Even though it is looking like 1D array, but it is not. Try to understand, because one row is there and 25 columns are there. We have reshaped ARR in this fashion. And why in this fashion only 1 into 25 is 25. So either it can be 5 into 5 or 25 into 1 or 1 into 25. So I mean, just make it correct. It is not 1D, it is 2D. I hope you are able to understand that. Okay, it is one row and 25 columns. You might be knowing in matrix we always represent row first and then the column. Yeah. Right. So that's what shape and reshape is. Always remember, shape is used to know what is the shape of the array, and reshape is used to change the shape of the array. Right? We will see how to make use of that in some examples. And now how to identify maximum, minimum elements in the array. Let's see. Array and ARR. This is what our array is. It's a one-dimensional array. These are the elements in array and ARR. Now I want to know what is the maximum element in array and ARR. So what I can do is array and ARR dot max and then run it. So it is going to show me maximum element from this array. So 33 is the maximum element, and that's how you can find out. So in this case, by looking at the array only, I can easily find it out. But in real time, this is not going to happen. In real time, you are going to get a lot of elements, right? So we are just trying to discuss very small example just for our understanding purpose. Okay, that is one thing. If I want to know what is the minimum element, what I can do is array and ARR dot min and run it. I am going to get minimum element as 1 because 1 is the minimum element in matrix. This is one thing. If I would have used something like this also, np dot max of array and AR, that's also possible. Numpy dot max, that's also possible. Okay. Otherwise, numpy dot min of array and AR. You should do bracket and then array and AR and then run. So one and the same thing. That is one thing. So this is my array and AR. Now let me show you array and ARR dot argmax. Now what is this? Argmax is maximum argument. Now what will happen because of this command is it is going to give you the position of the maximum element. So which one is the maximum element? 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. In our case there are two maximum elements. So it is going to give us the position of the maximum element. Let me show you. So what will happen? 1 is there and 8 is there, right? Let's see which position we are going to pick. So see, it is going to give the position of first maximum element. If there are repeated maximum elements, ARG max is going to give the position of the maximum element. That is one thing. And RA and ARR dot mean argument mean. So it is going to give the position of the minimum element. And which is the minimum element here? 1 is the minimum element. And what is the position of the minimum element? 0, 1, 2. So 2 should be the answer. Okay. So ARG max and ARG min are used for finding out the position of the maximum and minimum element in the array respectively. Remember that. Okay. So this is what RA and ARR and ARG mix, max and min is. Shape we have already seen. Reshape, this example we have already talked about. Okay. Data type also I have already told you. So that was in a brief about Numpy. There are other topics also like indexing and selection in case of Numpy. Numpy operations, and obviously there will be some exercise. At least for Numpy I will try to complete it so that in other cases we will not require much time. There will be no need for me to explain the things again and again, at least if you understand this particular. Okay. Let me talk about Numpy indexing and selection. So first of all, let us create ARR array once again. But in this case, try to see how are you trying to create it. np.arrange starting with 0 and 11. So starting point is 0. Even if I wouldn't have written it, then also it is same. Let me run it. Now my ARR is this one. Now let's see indexing and selection based on this ARR. There are different methods. Simple indexing is like this, right? ARR of 8. You might be knowing this particular notation, which we call it as slice notation. So let's try to see all those things. So here ARR of, suppose if I go and if I do 6, so 0, 1, 2, 3, 4, 5, 6. So I am going to take 6 as the output because indexing in Python itself starts with 6. Now you might be knowing if I go here and if I try to type ARR of maybe 0, it's going to give 0 element. If I type, let me take ARR. If I type ARR of 0 colon, it is going to give me 0 onwards everything, right? This is exactly similar to what we have seen in case of strings. ARR of 0 colon 5. So it is going to give me what? 0, 1, 2, 3, 4. These 5 elements it is going to give. Right? Because in case of Python, you know that this element will not be actually included. The element before this one, whatever is there after colon, the element before that is always included in the indexing output. Now here if I go ARR of, if I type colon only, it is going to show me everything. Remember this. Okay. If I type ARR, if I type ARR of colon, if I type 5, it means what? It means if I am not giving any starting point, by default the starting point is going to be 0. So it is going to give me 0 to 4. Right? This is the meaning of this particular. Okay. So that is how we actually go for indexing in case of arrays, which is exactly similar to what we have seen in case of strings. Now let's try to move and try to see something called as broadcasting. So to understand broadcasting, let me try to show you a simple example. See, this is what my ARR is. Now if I am going like this, ARR of maybe 2 colon 5. Now what is 2 colon 5? So it will give me 2, 3, so 2, 3 and 4. Right. Now what I will do is this ARR of 2 colon 5, I am going to assign it to some array. ARR2. Okay, so ARR2 is going to be what? 2, 3 and 4. 2, 3 and 4. Right. Now what I will do, ARR2 colon. What is this? ARR2 of colon? Every element from ARR2, that is 2, 3, 4. Now what I am going to do is ARR2 colon is equal to 55. Now can you people tell me what will be there in ARR2? What will be there in AR2? Yes, 55, 55, 55. That is right, Sean. Right. So let me show it to you. It will be all 55. 55, 55. Now, is there any change in ARR? Can you people tell me? Is there any change in ARR? So yeah, people are saying no. Okay, people are saying no. Let me show it to you now. See. Now see, there is a change in ARR. This is called as broadcasting. So try to understand. Actually, I did not make any change in error. That's what you people also felt, that there will be no change in error. But see, what I have done is I have actually taken a slice. I have actually taken a slice of error and I made the changes in that slice. I did not make any change in actual error. I made the changes in the slice. But those changes actually affected the original array, and that is called as broadcasting. Is it clear? So what I should have actually done is when I created this AR, where did I create it? Let me just try to see that. Yeah, when I created this ARR, let me create it once again. Suppose like this. Okay, I should have taken the copy of that. We can do alt copy then put it. Yes, yes, yes. So my purpose was to make you aware about what is broadcasting, and by default Python supports broadcasting. That's why always make a point that you take a copy. So ARR2 is equal to ARR.copy. You make a copy of this and then make the changes in ARR2, whatever you want. Okay, that is not going to affect ARR. That's what broadcasting is. I hope everyone is able to understand what is broadcasting, and that's what is actually explained here. Now, let's try to talk about indexing of a 2D matrices. Indexing of a 1D one-dimensional array is really easy. Let's try to talk about indexing of 2D arrays. What I am doing is I am creating a 2D array. np.array 5, 10, 15, 20, 25, 30, 35, 40, 45. Let's see some of the questions here, and let's see how many of you will be able to answer that. Okay. Now see here, if I go and if I try to run it, AR underscore 2D, shift enter. Now see, 5, 10, 15, 20, 25, 30, 35, 40, 45. These are the elements. Now, can anyone tell me what if, or maybe if you people are not aware about, let me show you. Suppose I want to grab 10. How can I grab 10? So you just need to use indexing. AR underscore 2D of, as I want to grab 10. So always remember how to do indexing in case of two-dimensional array. Zeroth row, first row, second row. Zeroth column, first column, second column. I want to grab this. That means zeroth row and first column I need to keep. Okay, let me show it to you. So here what I will do is zeroth row and first column. Let me check it. Now see, I got 10. I hope everyone is able to understand. The point you need to remember is that indexing or number of rows and number of columns in case of Python, actually in case of Numpy array, starts with zeros only, right? Now suppose if I ask you people, what if I want to fetch 45? Just tell me what should I do? ARR underscore 2D of 45 means what? 0, 1, 2, right? And 0, 1 and 2. Yes, it seems very easy initially. I will ask you questions. I will guarantee that you will not be able to answer. Many of you will not be able to answer some of the questions. See, in this case, second row and second column, that's why we got this. Right. Now, let's suppose, what if, let me write down this AR underscore 2D once again. Let me run it. Now, this is my AR underscore 2D. What if I want to grab 20, 25, 30? This again you will be able to answer. I want output as 20, 25, 30. Can anyone guess what you can do? I already told you, right? So Sharon is saying AR underscore 2D colon 1. We just copy his answer, paste it here, and let's see whether it answers our question or not. So Sharon, your answer is giving me this one. I wanted this. Are you getting Sharon? So we want what? We want 20, 25, 30. Okay. So Amin is saying AR underscore 2D 1 comma colon. Let me check Anil's answer. So 20, 25, 30. That's what right? So do not make any confusion here. There should not be any confusion. Rows always starts with 0, rows and columns. So many people they have tried it out. They find it correct. Okay, let me show you. Why is it right? Because see, 0th row, first row, and second row. There are multiple answers. This is right. You can go and you can write it down like this. Error underscore 2D of, suppose if I give 1, then also I will get the answer. Right? That's also possible. Instead of this, even if you do it like this, that's also possible. Suppose error underscore 2D of, if I go here and if I try to write down first row, right? So first row, and I want all the columns. Just put a colon here. That's what colon means, everything, right? Or otherwise, you go here and you try to write down 0 onwards everything. That's also possible. Or otherwise, this same thing can be written like this. Those people who understood basics of indexing, they will be able to get my point. If I go and if I try to write down 0, 1, 2, 3 here, again it is going to be the answer. Right? See, whatever you people have studied in case of AR. Now suppose, can anyone tell me what will happen here if I go and if I try to write down AR of, suppose we know that 5, if I give, I am going to get the answer as 5. Right? And if I give ARR of maybe 5 colon, it is going to give me the answer 5 onwards everything. What if I go and if I try to write down ARR of 99, can anyone tell me what will be the output of this? This is what your ARR is. There are 10 elements. Can you people tell me what will be the answer of this? ARR of 99? Nothing. Right? Like it is going to give me index out of range. See, it is going to give me index out of range. Index 99 is out of bounds. Because there are 10 elements only in here. If I go and if I try to check, there are only 10 elements. That's why this index is not there, because indexing values from 0 to 10 only. 11 elements are. What if? Now can you tell me what is the answer of this one? ARR of 15 colon. Can you people tell me what is the answer of this? ARR of 15 colon. Okay. Sharon is saying error. So Sharon, it is not going to give me error. That's what the point I want to clear here. This is not going to give me any error. Just try to understand that. It is not going to give me error. Empty array it is going to give me. Yes. Because always remember, slice notation never gets index out of bound error. Slice notation never gets index out of bound error. See, empty array. What will be the output of this one? ARR of 2 colon 1000. Just tell me. What will be the answer of this one? Can anyone tell me? Is it going to be error or what? 0 to 10? No, not sure. 2 to 10. 2 to 10 means 2 onwards everything it is going to show. Because indexing notation is never going to get, slice notation is never going to get index out of bound area. Even if it is 100, 1000, whatever it is, this is not going to matter. Because slice notation is there. See. Now 2 onwards everything it is going to show. Yeah. If it would have been like this, then it will show me. Because direct indexing is going to have index out of bound error. But slice notation is never going to have index out of bound error. Always remember that point. I have seen many experienced people also, they are confused with that. Okay, so I am just see, you people told me that you are aware about all these things, but I am just trying to go through all these things faster. Right? It is like there is then Pantal also, then there is Matplotlib also, Seaborn also. But as we need to stick to the syllabus, so I will also have to take care about all those things. Right? Otherwise, you people will say that syllabus is not complete. Right? That's why we will try to see all the things, but yes, we will have to limit ourselves because you people have some system to follow, right? And that's why whatever is required, that's what I'm just trying to touch, so that it will be easy for you to even understand the implementations. Those who are interested to go and develop some models. Definitely these things are going to help. Okay, so that's what the indexing is. Now let me go and try to continue our discussion with this topic. Okay, AR underscore 2D. So you people are able to tell me that how to get this row, how to get this row. What if I want output as from this AR underscore 2D? Just tell me what if I want the output as this. I want 10, 25, 40. Can you people tell me what should I write down? AR underscore 2D of what? I want I want the output as 10, 20, 40. 10, 25, 40. Whatever is highlighted here. Just let me know what can I write it down. Yes. Okay. Saloni is saying colon comma 1. So colon means all rows, comma 1 means the column at the first index. So 10, 25, 40. That's what the right answer. Again, there are other possibilities also. Yes, all other people are also right. Sharon, I mean, people are also right. Okay, so you people now are able to understand how to fetch a single element, how to fetch a complete row, how to fetch a complete column. What if, suppose, if I ask you a question, what if I want to fetch maybe these two elements, 35, 40. I want 35, 40. I want to fetch 35, 40. Those people who have any question about practical applications of this, there are a lot of practical applications for this. Because at the end of the day, your image is going to be stored in this session. Okay, so Monisha only is saying the answer. I'm just trying to copy that answer. Just a minute. 0 colon and then 1 colon 2. That's what our answer is. So 0 colon comma 1 colon 2. Let me type here. 0 colon comma 1 colon 2. So 10, 25 and 40. Right? But what we want, Monisha? 35, 40. Just try to make the corrections. We want 35, 40. Okay, okay. No problem, Manisha. You said for previous, but we want answer for current. So who is saying okay? Vibor has answer, Amin has answer, and these two people. Let me copy Vibor's answer. We want 35, 40. Let me check. So Vibor, this has given us 35 only. We want 35, 40. Your answer has given us 35 only. Let me try out with Amin's answer. This is what his answer is. Yes, this is what the answer is. 35, 40. Those people who tried but not able to get, just check it. This is what the correct answer is. Right? Or otherwise, there are other ways also. What happens is error underscore 2D. This is what your array is. I ask you people to face this. Now, what you need to do is just try to check what is the row number and which are the columns. So, just go here error underscore 2D of what is the row number? Row number is 2. Comma. What is the column? You want 0th column and first column. Right? That means what you need to do is 0th column and first column. How are you going to get? Just do it colon 2, because we know that whatever is there after the colon, that is never going to be considered. So just type it like this, and you will be able to get the answer. Right? 35, 40. I hope everyone is able to understand that. Or otherwise you could have written it like this, 0 colon 2. That is also one and the same. Okay. So see, Sharon, my question was, I want to grab this one, 35, 40. So how to answer this kind of questions? Just check which row it is, 0, first and second. So first of all, check the row for your required elements. What is the row? Second row. And what is the column? 0th column, first column, and second column. So in which column it is there? In these two columns. So we know that what we do is AR underscore 2DR, we represent row number here, and then we represent column number here, right? But what row we want? Second. That's why I have 2 here. And what columns we want? So we want 0th column and first column. But how to get 0th column and first column? So 0 colon 2. Intersection of these two is 35, 40. Is it clear, Sharon? You asked me to repeat it. Yeah. Okay. So see, that's what I hope everyone is able to understand. Okay. Now let's see how many of you will be able to answer. What if I want to grab? Suppose I want to grab maybe 25, 30. Give me the answer for this. 25, 30. Let's see how many of you will be correct. Again, it is exactly the same thing. Whatever we have done, just try to observe which row and which column, and the intersection of these two will be your answer. So I got the answers for Amin, Vibor, and Aman. Let me check Amin's answer. Okay, this is what Amin has written. 25, 30. So try to observe it. Right? This is right. I hope everyone else is also right. 25, 30. This is what you are going to get. I hope everything is clear. Like this, you can go and you can try out different questions. There will be one question I think you will not be able to answer. Maybe you will require some time for that. Maybe you can have a thought on that. Let me ask you. See, now here, whatever you people are answering, that is right. So 25, 30, we got it like this. Because we wanted first row and elements from which column we want? These two. So one onwards everything in column you can do, and in case of row you can do like this. That's for this answer. Okay. Now there is a question for you people. What if I want to grab? What if I want to grab 5 and 40? Try to answer this. I want to grab 5 and 40. Let's see now how many of you will be able to answer. 5, 40. And those people who are having questions, why are we discussing all these things? Because see, if there is an image, and I told you, image can be stored as a collection of pixels, and pixel is nothing but array or matrix, right? So from an image, there will be a question. You need to grab anything, right? You need to grab anything. That's why we are learning. So Saloni has given me some answer. Let me try it out. This is what she is saying. Let me add on here underscore 2D here. Saloni, let's see whether your answer is right or wrong. So it has given me 1510, Saloni. What I want is I want 540. Right? That is not right, so 1510 your answer is given. I got another answer from Amin. Let me check it. I copied Amin's answer. Let me paste it here. Let's see whether Amin is right or wrong. 540. So let's see. 540. This is what we wanted. So see people, Amin is right. He has got the answer as 540. This is what his answer is. Okay. I think I got another answer also. Okay. Sharon is saying 0, comma, colon 1. Okay, that is not going to work, Sharon. Whatever you are trying to say, let me see. Here underscore 2D off. This is what you are saying. See, this is not going to work. Too many indices. That is not going to work, Sharon. One more person has answered it. Monisha Kohli. Again, this is also not going to work, Monisha. Let me show it to you. ARR underscore 2D off. See, because that's a incorrect syntax. We wanted 540. This is what we wanted, 540, and yes, we got the right answer. This one. So see, always remember what we need to do in this case is if the elements are not adjacent, what you need to do is 5. 5 is present in which row and which column? 0th row and 0th column, right? So 0th row. So for this 0th row and 0th column, and 5 for 40, it is second row and first column. Okay, so just check 540 0th row. Here it is given as 0th row. So whatever rows you have, and what I meant to say is just try to see. I wanted 5 and 40. Which row is here? 0th row. For 40, which row? Second row. So you just need to make rows at one place. You just need to write down number of rows at one place. And which column? Zeroth column. For 40, which column? First column. So for this, you make another couple. So these are the rows and these are the columns. That's why he has written it like this: 0, 2 and 0, 1. 0, 2 and 0, 1. I hope everyone is able to understand that. Right? So one more example if you want. Error underscore 2d of, see, what if I want to grab, suppose what if I want to grab maybe 10, 30. Try to answer this. So 10, 0th row and 30 is first row. So 0th row and first row. And this one is what? First column and second column. First column and second column. So whenever elements are not adjacent, you can go it like, you can go and you can do it like this. So I am getting answers from here, right? So yes, 0, 1, 1, 2. Always remember. For which types of questions you should write down this? For the elements where for the questions where the elements are not adjacent. So 10. That's right, sure. Again, there are other types of questions also which we want to discuss. Maybe we will see that in the next session.